Hi, we're Solo 5.
I'm Kevin Carlson.
I'm Monica Riturban.
I'm Laurie Nakagawa.
I'm Joanne Cho.
I'm Huynh.
And we have designed the delivery system for Pizza Solo.
And for our agenda, we'll be talking about the background, problem statement, methodology, literature review, the experimentation, results and analysis, and finally, the conclusion and recommendations. Pizza Solo is a local restaurant located in San Luis Obispo, and it has been open since August 1996. Currently, Pizza Solo is using third-party vendors to deliver their orders. We worked with our stakeholder to establish the following problem statement. Marth Pearl, owner of Pizza Solo, wants a cost-effective, in-house delivery system that utilizes an electrical bike.
Based on the problem statement, these are the project constraints identified. 1. For the system to be considered green, the provided electric bike will be utilized. 2. It must cover a 2-mile radius, which includes the Cal Poly campus. 3. Deliveries must be made within 1 hour of the order. 4. It must meet current demand. And 5. It must be scalable to meet increasing demand. These are the deliverables that Solo 5 agreed upon with Marth Pearl. A training manual for future delivery employees, cost and payback analysis to compare the current and proposed systems, a simulation of the delivery system to show how the system will meet scale demand and time constraints, and the system process flowchart to outline our design.
This is a diagram of the prototyping methodology we applied in order to find a solution for the problem statement. First, we started by defining the problem. Next, we conducted field research and collected past data to have a better understanding of the current delivery system. Then we performed a quick and dirty simulated delivery run in order to discover any problems that we may have not thought of. After understanding the current delivery system and identifying any additional problems, we apply the things we've learned to help build our delivery system design. We would then test our design by prototyping or implementing dry runs. If our design did not run smoothly, we would factor in the dry run's results and findings into our systems improvement design. We would then test our improved system design and reiterate this test and improved design procedure until we achieve a proposed system that we believe is ideal. Then we would create a simulation model of our proposed delivery system to discover its capacity limits. Next, we would analyze the results from our proposed delivery system and simulation in order to draw conclusions and make recommendations.
As part of due diligence, we researched and reviewed previously existing literature relating to the proposed system prior to major testing. We learned the following. 1. Restaurants utilize unique delivery systems, which are often patented, in order to compete with one another. In our case, Pizza Solo will be the only restaurant in San Luis Obispo to deliver via electric bike. 2. Are electric vehicles emission-free? Our research shows that electric vehicles do indirectly create emissions through increased demand on the power grid by engaging fossil fuel-burning resources. These emissions, however, pale in comparison to those created by internal combustion vehicles. With regards to our system constraints, e-bikes place a negligible demand on the power grid and therefore can be considered emission-free. 3. Heat sleeves are a food temperature and quality preserving tool universally utilized among pizza delivering restaurants. 4. For purposes of federal law, e-bikes are regarded simply as a bicycle, not a motorized vehicle. Thus, they are regulated by the Consumer Product Safety Commission. 5. Bikes are a preferred method of medium-range travel, as they provide higher maneuverability and variable route options in metropolitan areas where high traffic may occur. Further justification and research can be seen in the written report with this literature review.
For our experiment, we did data collection, which we gathered with surveys and tried to find the daily and weekly demand. We also created a simulation model of our proposed delivery system design to determine at which demand would require a second bike. And we performed dry runs, which we could test the temperature and food quality, time studies, and the battery life.
As for our field research, we survey random potential customers and competitors such as Domino's, Petra, Woodstocks, and Batty's to help us determine our main objectives of the delivery system design. We have asked random potential customers to fill out a short survey regarding pizza deliveries. We found out that majority of the customers don't mind paying a small delivery fee, and the two most important factors were that the customers care about the quality of the food and fast delivery time. After surveying local competitors, we found that if there is a high demand of orders, competitors will send out one car per order to deliver. Currently, Pizza Solo will be the first local restaurant to implement a bike delivery system. Using a bike will help market Pizza Solo's brand and distinguish them from their competitors.
From the delivery order receipts, we found the peak demand times to be around lunchtime, 11 a.m. to 1 p.m., and dinner time, 5 p.m. to 8 p.m. We also found that the current demand is low, being a demand of 1 to 3 orders a day.
Our proposed delivery system includes the utilization of one electric bike. We wanted to see at which level of delivery demand will overload our proposed system, so we've created a simulation model that emulates our proposed system. In this model, we are concerned with three metrics of the system. Number 1, the delivery lead time, the time difference of when a customer places an order to when they receive it. Number 2, food waiting time, the time that the order is waiting at Pizza Solo for the bike to return to pick it up. Number 3, number of late orders. An order is considered late if the delivery lead time is more than 1 hour. From our simulation results, we find that our proposed delivery system has the capacity to meet current delivery demand and also with increasing demand. However, our system failed to meet project requirements once the demand increases to 1 order in every 25 to 30 minutes. If delivery demand reaches that level, the capacity with 2 electric bikes will be necessary in order to retain the project's requirements.
In our dry runs, we tested and measured the temperature and food quality using these parameters, as determined to be important factors from our survey. After several runs, it became apparent that the temperature was an issue and required more attention. Upon completion of this testing phase, the data results showed that the food quality and temperature was unacceptable after 30 minutes of the order leaving the kitchen. The total delivery lead time is required to be less than 1 hour. In our time studies, we found that the delivery system's lead time is approximately 30 to 40 minutes. This time includes kitchen cook time, load time, travel time, and delivery drop-off time.
During our dry runs, we tested the limits of the bike's battery life. The bike can last about 8 hours. However, Pizza Solo opens for about 10 hours a day. In case of battery depletion, an extra battery would be needed.
The total cost to implement our proposed system is about $4,500, which includes the cost of the electric bike. With the current system, the gross margin percentage is 45%, which incorporates the food cost as well as the third-party vendor cost. On the other hand, the proposed system allows for a gross margin percentage of 52%. This increase is the result of using in-house staffing rather than outside vendors, revealing a payback period of 1.11 years based on current demand. If the demand were to increase, which is very likely through marketing plans, an even larger profit margin will show, and as a result, the payback period will shorten, as seen in the graph. For example, if the current demand doubles to about 3 to 4 orders per day, the payback period will decrease to a little less than 7 months, while if the demand jumps to 1 order per hour, or 10 orders per day, the payback period will drop to 2 months.
In conclusion, we have tested and analyzed the following 5 categories. We were able to determine that no more than 2 destinations per delivery should be attempted in order to ensure optimal food quality and to also keep within the delivery lead time promised. Our time studies proved that both 1 and 2 destinations in a delivery run will have a lead time of less than 45 minutes, which meets our requirements for the system having a lead time being less than 1 hour. The battery life has 8 hours of runtime per charge, and with the current demand can last the whole day on a single charge. However, should the demand increase, another battery would be ideal to have as backup. The current daily and weekly demand are easily manageable with our one bike system, but should demand increase to an average of 1 order every 30 minutes, then a second bike would be necessary to maintain our 1-hour policy and to meet the larger demand. Pizza Solo can expect a payback period from the system implementation costs to be a little more than 1 year with the current demand, but should the demand increase, then the payback period will decrease. Now that we have completed analyzing our system, we have some recommendations to propose. Due to the current low demand of the delivery system, it is more reasonable to hire the delivery personnel as part-time during the peak delivery times as determined by our data collection. Once the employees are hired, they can use the training manual that we created to learn the delivery process. Martha also recruited the help of a web developer to create a plugin for the current website and to process orders. We gave recommendations on how to integrate it with our system, such as delivery fees. As stated before, a second bike and/or battery will be necessary with an increase in demand.